All right, so yesterday we learned about trapezoids and kites. We learned that a trapezoid has one pair parallel sides, exactly one, no more, no less. We learned that an isosceles, which would have the legs are congruent, has congruent base angles and diagonals are congruent. Then we learned about kites. And the kites have two consecutive pairs of congruent sides. So it can't be a rhombus because then it would have all, like they would be consecutive. All of the sides would be congruent. And they're not opposite because then it makes a parallelogram, and kites and trapezoids are not parallelograms. We learned that in a kite, the diagonals are what? Nope. Perpendicular. Okay. And what? We learned one more thing about kites. Yeah.
That the two opposite angles are equivalent.
Good. So angles where the non-congruent sides meet. Are congruent. So like if we have this, unless these two would be congruent, okay? And then we learned about the mid-segment. Of a trapezoid. Okay, which connects the midpoints of the sides of the trapezoid. And it is equal to base 1 plus base 2 divided by 2.
How do you get like the base 1?
We did it. We met those questions at the end that you took the picture of. Those were those. So you find there's two ways.
Yeah.
Yeah. Yeah. You either use that formula and set it equal to the mid-segment, right? You'll have one of the bases. Or you just find the difference between the mid-segment and the base. And if you're missing the small one, then you go down from that.
B2 minus mid-segment.
And then, no, B2 minus mid-segment is the difference. And then you would subtract that difference from the mid-segment. And you get the B1. If you have a specific question from the homework, I'll screenshot it. Then you add it. Find the difference and then add it to the mid-segment. Yeah. And then the mid-segment is also parallel to base 1 and base 2. So all those things were like in the notes from yesterday, okay? So if you're, hold please, if you're keeping a note that has all this information, which I would strongly recommend, obviously, because it's a lot of stuff, I would add all that stuff from yesterday. We're going to do a little bit of that towards the end of today, but I would say a lot of that prep work you need to do on your own so you make sure that you remember it. Yes, Kumar?
Can you go back to kites?
Yes. All right, so number 1 says find the measures angle A, C, and D. This is what type of shape? Specifically an isosceles trapezoid. I know that because the parallel marks show you it's the trapezoid. The congruency marks show you it's an isosceles trapezoid, which means base angles are the same. This would be 56 degrees. And then how do I find the other one?
They are consecutive and supplementary.
Good. So consecutive angles are supplementary. So 180 minus 56 is?
Angle D and angle A are 124
Good.
degrees. Yay.
Yep.
Isn't the whole inside of the trapezoid 360?
Yep.
So you can subtract.
After you get the 56, you mean? Yes. After you get the 56 on the other side, then you can add them, subtract them from 360, divide by 2. Correct. Oh, okay. All right, 2. Find the length of the mid-segment of the trapezoid. So this time you've got base 1 and base 2. I'm going to add them and divide by 2. I get 50 divided by 2, which gives you, I'm sorry, what? 25. All right, 3 and 4 are now based on, well, 3 is based on the kite that's drawn there. Again, I know it's a kite because of the congruency marks. This one is next to this one, and this to this. So there has to be two, and it has to be two different lengths, and they can't be opposite each other to be the kite. So it says if angle XYZ, which is this one, is 80 degrees, and XWZ, which is this whole one, is 48 degrees. Find the measure of YZW, which is this whole angle.
Wait, why isn't XYZ the whole angle?
Why isn't it, or why is it?
Why isn't it?
Why is it?
Why isn't it?
It is. The purple thing is that whole thing.
No, wait, could you put the 80 on just one side?
XYZ. Oh, this 80, XYZ would be that whole angle. Okay. All right, so go.
I got that.
I see.
Hang on, Santi, let him talk. Yeah.
Equal 26, I did that by adding 80 and 48.
Okay.
28. I subtracted that from 180. And then I divided the difference.
Why are you subtracting from 180?
I actually know an easier way.
You'd have to subtract from what?
360?
360. So the 4, it's still a quadrilateral. They would have to, right? Does that make sense? And then divide it. Does that make sense? Because it's still a quadrilateral. All 4 interior angles would have to add up to 360. So if you add the 80 and the 48, which is one way to do it, this would have to be 232 divided by 2. And then that's 116 for both of these. Okay, so you have to remember that those are congruent in order to do that, right? And they are, because that's where the two non-congruent sides meet. Anybody do it differently?
I did. You just threw me off. You said 180, and that was completely incorrect.
Oh, thank you. Okay, it would complicate it a little bit more, but you could divide these angles in half and then use the right triangles, because if they are perpendicular, right, this would be 90. You could find the complement to 24, and you could find the complement to 40, and then you could add them together, 66. And you could also get the 116. So there's a couple different ways to do this, which might be beneficial if you're trying to check your answer.
Would you say it's the easiest?
Probably the first way, like subtract them from 360 divided by 2.
48 and 80 are bisected?
40, yes,
Are they always going to be bisected, those angles?
yeah. Because they're 4, this is a triangle that's congruent, this is a triangle that's congruent. I mean, those two are congruent to each other, right? Because they would be
Okay.
hypotenuse leg. So those would be congruent triangles. All right. 4 says true or false. One pair of opposite angles of a kite are congruent.
Ooh.
Exactly one pair, right? Is it of a kite? Yes, all the time?
Yep.
Yes.
Wait.
He didn't lie to me.
I thought there's 2 pairs of opposite.
No, only one pair. If it's 2 pairs, it makes it a parallelogram, and kites are not parallelograms.
There's X and Z, one pair, and then W and Y the second pair.
Right, so these two are congruent to each other, but
80
these
and
two
40
are not.
congruent?
Oh, wait, there.
No, and they cannot be. It's not just that they're not this time, but they cannot be. Otherwise, it makes it a parallelogram, and a kite is not a parallelogram.
My fault.
Yeah.
So would there be questions like this on the?
True or false? Yes. Okay. 19. All right, so you're opening this. We're going to do this again, okay? This is the properties of quadrilaterals. So we just did the kites and the trapezoids. We're going to go back to the quadrilaterals, parallelograms, rhombuses, squares, and rectangles. Everybody should have this PDF open in front of them. Let's be grown up so I don't have to lock you in.
I had it.
I figured. All right, we're going to build this together based on all the stuff we know. So, properties of quadrilaterals start on the outermost ring, okay? What's the properties of quadrilaterals? What's the definition of a quadrilateral? I didn't expect to stump you on that one. 4 sides. And then what's the one other thing we know about quadrilaterals? Not necessarily. Now, that's what you're getting in a parallelogram. So this is just quadrilateral, any shape with four sides. There's one more thing we know that has to be true at all times about the angles. Specifically, the sum of the angles. Good. Sum of interior and technically exterior, because that's always for quadrilaterals, equals 300 angles, interior angles. So that is true for every quadrilateral, anything that has four sides. Then we narrow it down to a parallelogram. So by definition, a parallelogram is what?
You move back up to parallels.
What's the definition of a parallelogram?
Well,
Not congruent. Parallel. Both pairs of opposite sides. All right, so that's the definition. Then we got into our theorems that said the properties of them. So give me a property of a parallelogram. Of a parallelogram. There were 5 things we know about every single parallelogram. That's the first one. Opposite sides are congruent. Give me one more. Opposite angles are congruent. Opposite angles are congruent. And this is called the parallelogram opposite angles theorem. What's another property of parallelograms? Diagonals bisect each other. And this is the parallelogram diagonals theorem.
So we're gonna have to like know these.
Yup.
Complementary lines or stuff. I mean,
Consecutive. That's based on the parallelogram, though. I mean, we can add it because there's not a theorem for that, but you can add it because the parallel sides. So consecutive angles are supplementary. Okay, that doesn't have a theorem name. It is true, but it doesn't have a theorem name. Yes?
I didn't know it was my.
You didn't?
I didn't know it was my 8th birthday this month.
Thank you for sharing. All right, give me another property. Opposite sides are congruent. And that's parallelogram opposite sides theorem. We'll get to that in a minute. All right, give me properties of rhombuses.
Alright, so
Let them go.
all 4 sides are congruent,
4 congruent sides, and that's the definition.
but opposite angles are.
But that's because it's a parallelogram. What does a rhombus add that all parallelograms don't have to have? Wait.
That all the sides are congruent.
Mm-hmm. And then there was 2 theorems. Do you remember what they are?
Seems to not remember.
Okay.
Bisect names.
Diagonals bisect opposite angles. Okay, and there's one more. Yep.
The 2 opposite sides are parallel.
But that's from it being a parallelogram. There's something more specific to a rhombus.
That.
Yep.
Wait, the diagonals intersect at 90 degrees?
Good. Diagonals are perpendicular.
That's literally a square.
Well,
Square
funny that you mentioned that because all of the properties of a rhombus apply to a square, right?
True. But also the diagonals bisect the angle.
We said that, yeah. Okay, properties of rectangles. So what's specific to a rectangle? Definition of a rectangle?
All the sides are 90 degrees.
All the angle, good. 4 90-degree angles. I knew what you meant.
It's like literally the square.
Okay. And what's the other property that's specific to a rectangle? Which one? Of,
Of lines.
what kind of line? Nope.
Nope.
There's one property that's true for a rectangle. It's about the diagonal.
Diagonals bisect and,
That wasn't it.
90 degrees.
Yeah.
They're not 90 degrees.
Yeah.
All the like all the segments that are diagonal equal each other.
Diagonals are congruent.
Yeah. I think he's smart.
He is smart, as are you. Also, a little bit of a smart aleck, but also smart.
True for rhombuses or?
It can be, but it doesn't have to be. So if it said the diagonals are congruent in a rhombus, like true or false, it's false because it doesn't have to be. Can, if it's an always, sometimes, never, then it's sometimes true because it can be.
Unless it's a square.
Correct. So then all the properties, so like that's obviously the properties of the quadrilaterals trickle down to the parallelogram, trickle to the rhombus, trickle to the square, trickle to the rectangle. Hold on. All the properties of a parallelogram trickle down to a rhombus, to a square, and to a rectangle. And all the properties of the rhombuses and the squares trickle into the, rhombus and the rectangles trickle into the squares, okay? So I'm gonna erase those arrows because they got confusing. But know that if it's, like this is a Venn diagram in actuality. Anything that's in the big box is true about everything that's smaller. And then so it works its way down. So everything that's true about a quadrilateral is true about a parallelogram. All of those would be true about a rhombus, a square, and a rectangle. And again, the square is the most specific, okay? It is a cross between the rhombus and the rectangle. Jonathan. So a correction on this one. This does have a name. This is the parallelogram consecutive angles theorem. That is one of your 5 methods. So the first one is the definition, but the rest are all theorems. Add the only other thing in between the kites and the trapezoids and all that stuff was proving quadrilateral is a parallelogram. There were 5 ways to prove a quadrilateral is a parallelogram. Give me one.
The opposite angles theorem converse.
Parallelogram, opposite angles, converse. Okay. Yeah.
Parallelogram, opposite sides, opposite sides, converse.
Prove opposite sides. Congruent, parallelogram, opposite sides, converse.
Isn't it just this slide in this question?
Sorry?
Isn't this slide?
Yes. Third. Yeah.
That the opposite sides are parallel.
Prove opposite sides parallel. Is that a theorem?
Yeah.
Nope. What would that be based on? Mm-mm.
Based on, what do you mean?
The definition. So like if you were to give that as a reason, it's the definition of a parallelogram. Okay, there's no theorem.
I could just say prove opposite sides are parallel.
Not if you're giving it as a reason in a proof, right? Yeah.
The parallelogram diagonals converse.
Okay, diagonals. Prove diagonals. Bisect each other. And that's parallelogram, diagonals, converse. One more, yeah.
Opposite side is parallel and congruent.
One pair, opposite sides, parallel and congruent. And this is just parallel and congruent. Whoa.
That's what I was trying to go for him to.
This was not a converse because we didn't have an initial one, right? There is like one other way, but it's not a one-step process, and that is to prove that the sides are parallel using consecutive interior angles. So if you had consecutive interior angles, you could prove the sides are parallel, and if the sides are parallel, then you could use the definition of a parallelogram. So that one is a two-step process. It still works, but it's a two-step process. It's not a one. Okay, and then 7.1 was all the formulas about interior angles and exterior angles, right? So the sum of the interior n minus 2 times 180. I don't know why I wrote it up there. Sum of exterior. So each interior, again, has to be regular, which means all congruent sides, all congruent angles. Each exterior, again, regular. 360 over n. And then we did like the applications of these. Like if I gave you the interior one, how do you find n? If I gave you the exterior one, how do you find n? And for those, finding n. For interior, you would do whatever's given equals 180 times n minus 2 over n, and then solve for n. So multiply by n on both sides, distribute the 180, subtract what the 360, or subtract the 180n, and then divide. Finding n for exterior, the number equals 360 divided by n, so I can actually just do 360 divided by the angle measure. You don't have to do it twice. You can do one or the other, but it's easier to solve the bottom than it is to solve. Those give you the same. You'd have to multiply by n, right, on both sides. And then you'd have to divide by 360, or divide by the number. So you just do, this is what is easier to do. All right, your homework is the chapter review. There are tons of resources on that module 2 with all the information we went over. But make sure that chapter review is done by Monday so you know what you need help with on Monday. Have a fantastic weekend, guys.